Okay, so here's our tutorial on multiplying matrices. This is just a quick review of the properties of matrix multiplication. So we do label a matrix with a capital letter. It doesn't really matter which capital letter, but if we were multiplying matrix A times matrix B, the result would be a matrix called AB. We don't need to show the dot in the resulting matrix, but we do show the dot in the actual multiplication step. M times N would be the dimension of A. Again, over here we see that M is representing rows, N is representing columns. In matrix B, N and P, again, just because the variables switch doesn't mean that the order of the rows and the columns switch. It's always the first term is the rows, the second term is the columns. So when N and N are the same, these two matching interior terms of each matrix, if they're the same, then they can be multiplied, and then the resulting matrix is going to be the outer terms, so our M by P, and those are going to be the dimensions of the matrix. So let's get to an example. First, we should test if this can be multiplied, so we're going to check the dimensions real quick. The dimensions of our first matrix are going to be 3 rows, 1, 2, 3 rows, by 2 columns. Our second matrix is 2 rows by 2 columns. So because our interior terms do match up, this can be multiplied, and the resulting matrix is going to have the dimensions of the outside terms, so 3 times 2. So we can set up an answer matrix just to give us an idea of where we're going and what our answer should look like. So we're going to have 3 columns, 1, 2, 3 possible answers, and 3 rows and 2 columns, 1, 2, 3 in the second column. So we're going to have 6 different terms in our resulting matrix. Now, as we work through, the answer in the first row and the first column should be using information from the first row of the first matrix and the first column of the second matrix. So here's where I'm going to show my work, and I'm going to use a work matrix so that we can follow the pattern. So as I work over, I'm going to use red to go over along the row, and I'm going to use blue to go down along the column, and we'll see where the numbers from each give us our answer in our work matrix. So our work matrix is just going to be an expanded version of our answer matrix, but we're going to keep all of our work there. So the first term in row 1 is going to be placed in row 1, so 0, and as we start at the first entry of the row, we're also going to stop at the first entry of the column in the second matrix. So we're going to do 0 times -4 plus, then we shift over along the row, we multiply 5, and we shift down along the matrix times -2. And our resulting answer is going to be 0 plus 5 times -2 is -10. So the sum of those two things will go in our answer matrix, and that's going to replace the row 1, since we used all of the information from row 1, and column 1. So here again, we're in row 1 of the answer, column 1 of the answer. Now we'll do the same thing with row 1, but this time we're going to be using the numbers from column 2, and therefore our answer will go over in row 1, but column 2 instead. So again, we have 0 times, and here we're starting with the first column, column 2, the first term in column 2, 4, plus, we move over along the row, 5, and then we move down along the column, -4. 0 times 4 is 0, 5 times -4 is -20. So again, we're going to replace our answer space with the results of our matrix from row 1, column 2, we'll put the answer in row 1, column 2 spot. So we have negative 20. All right. Now I move on to the second row. So the second row is going to use the terms 3 and 1. And since we're going to work in the first row first, so I can move over negative 3, move down the first column, negative 4. As I move over, I'm going to add 1 times. I move down through the column, negative 2. We can add these up. So this is going to be positive 12 minus 2. So this will be replaced with a 10. And again, I'm going to stay in the second row and this time use the second column. So I will have negative 3 times 4, which is the first term of column 2, and 1 times, and move down the column, negative 4. And again, with my calculations, I'm going to have negative 12 minus 4, so I should have negative 16. And then the last row we're going to have, we go across, I have negative 5. I'm in the first column, so I negative 5 times negative 4 plus 1 times, I move down the column, negative 2. So we have 20 minus 2, which is going to replace the third row, first column. And last but not least, third row, second column, we're going to have negative 5. Moving down the column is 4 plus 1. Moving down the second column is negative 4. So here again, we do the math. Negative 20 minus 4, and we get a negative 24. And this is our answer matrix. Now, if we look at our work using the colors, we can see a pattern. All of the numbers that are in row 1 that were being multiplied as a row are in blue. So all of our negative 4s, because it was the first term of the column, and all of the negative 2s, because it was the first term of the column, up here. Same with the blue in the next column. All of the 4s are first, all of the negative 4s are second. So we really do see the pattern with the colors. And 0 and 5 are repeated because those were the numbers from each row. Negative 3 and 1 are repeated in green, and negative 5 and 1 are repeated in yellow. So color coding really does help if this is something that you're having a hard time with and you would like to color code. In the beginning, it really does help you check to make sure you're putting the right numbers in the right places. Alright, so that is a quick tutorial. We will finish this up in class when you return.